Hi, welcome to the class. Today we will understand wave optics, and within wave optics the very first topic which we have to study is about wavefront, right? So we understood that light moves as a ray, and when light moves as a ray it is what we call ray optics, right? But when light moves as a wave, it doesn't move in the form of rays, it moves in the form of something known as wavefront. Now what is wavefront? So if I can take an analogy of equipotential surface. So equipotential surface was a surface which was made up of many points, and each and every point on that surface was at the same potential, right? So similarly wavefront is a surface. So it is a surface. So it is a surface, and the points on this wavefront, these points on the wavefront, they have the same phase. So wavefront is a surface which is made up of number of points, and these points, all the points are in the same phase. So this is what we call wavefront, right? So whenever we talk of light moving as a wave, it moves in the form of wavefront, right? Now one should understand, like we studied in equipotential surface, that electric field is always perpendicular to the equipotential surface. In this case, we have rays are perpendicular to the wavefront. So rays are perpendicular to the wavefront, right? And what does rays do? They basically gives us the direction in which the wavefront will move. Okay, so rays basically indicate the direction of motion of the wavefront. This is what the rays do, right? Now we have, depending on what kind of light source we have different kinds of wavefront. Like for a point source, if you have a point source, so point source of light, if you have, the wavefront will be spherical wavefront. So this is a spherical wavefront. So this is the point source, and these are the light rays coming out. So these are the light rays which are perpendicular to the wavefront. So these are perpendicular to the wavefront. So if you have a point source, the wavefront are spherical. So wavefront is something which is three-dimensional. If you have line source like this, the wavefront would be a cylindrical. So wavefront be a cylindrical wavefront. If you have a line source, the wavefront will be cylindrical. And if you have a light source which is at infinity, then the wavefront would be the planes. The wavefront would be the planes, and here also the rays would be perpendicular. These are the rays which would be perpendicular. If you have light source at infinity. If you have light source at infinity, basically the light rays would be coming parallel to each other. So the light rays would come parallel to each other, and in this case the wavefront would be these planes. So I am not drawing a plane like this. Actually this will be a plane like this, but I am just drawing a simple line. This line represents the plane which is the wavefront for a light source which is at infinity, which is situated at infinity, right? So this is about the wavefront. How do we define wavefront? And we have different types of wavefront depending upon the source of light, right? Now wave theory, or that is wave optics, is totally driven by something known as Huygens principle. So Huygens was a scientist, physicist, who came up with this idea that light not only moves in the form of particle nature, but also moves in the form of waves. So he, first and foremost, he tried to explain by giving a theory how the light moves as waves. Okay. So what he said was, the very first thing which he said was that as I told you, the wavefront is made up of a number of points. So he started with the first thing which he said is this, that these points on the wavefront, so the points which are there on the wavefront, he said that these points on the wavefront are the secondary source of waves. These points on this wavefront are the secondary source of wavefront. It means these points can produce waves, and these waves are known as secondary wavelets, right? So these points on the wavefront are capable of producing a wave which is known as secondary wavelets. So this is the first thing which he said. Now the second point which he mentioned was that the points are making the waves, and these waves are moving in all possible direction with the speed of light. Now what is the speed of light? 3 into 10 to the power 8 meter per second. This is the second thing he said. First thing he said that the points on a wavefront are producing their own waves. These waves are moving in all possible directions with the speed of light. This is the second thing which he said. And the third thing which he said is this, that if we draw a tangent to these waves in the forward direction, the tangent drawn to these waves, which waves? Which are made up by the points on these wavefront. So the tangent drawn in the forward direction by these waves gives us a new wavefront. So if I draw a tangent, so this is a tangent which is drawn to these waves. These waves are made up of the points which are on the wavefront. These waves spread out in all possible direction with the speed of light. So the tangent drawn to these waves in the forward direction gives us the new wavefront. So what is the new wavefront? This is the new wavefront. And this is how the light as a wave move in a space. So what happens? We have something known as wavefront. There are points on the wavefront. These points are capable of producing secondary waves. And when they produce secondary waves, what happens is these waves move in all possible direction with the speed of light. And when we draw a tangent to these waves in the forward direction, it gives us the new wavefront, right? So this is what Huygens principle stated about how the waves moves, right? Thank you.